dealing with public health response and working with public health officials and how to respond, how to interpret and build policy around the data that is coming out of pandemics. So our first speaker is Professor Christian Happy. So he is a professor of molecular biology and genomics and the director of the World Bank-funded African Center for Excellence in Genomics of Infectious Diseases. This is in Redeemers University in Nigeria. So Christian did his postdoc at Harvard University and then worked there as a research scientist and then became an adjunct professor at the school, Harvard University School of Public Health. He has received numerous awards for all the work that he's done in pathogen surveillance and following the pandemics and epidemics in Nigeria and across Africa. And he, particularly for SARS, he used next generation sequencing platform of his to sequence the first SARS-CoV-2 isolate in Africa 48 hours after receiving a sample. This and other work that he's done has been seminal, not only in providing insight into the transmission of SARS and the origin of the virus, but also paved the way to the development of new diagnostics, therapeutics, and vaccines. So Christian is our first speaker. I'm going to just talk about our second speaker. So we're also going to have Associate Professor Trevor Bedford. So he is an Associate Professor in the Vaccine and Infectious Diseases Division at the Fred Hutchinson's Cancer Research Center. He's also affiliated, is an affiliate in the affiliate faculty at the University of Washington. His research focuses on phylogenomic analysis of pathogen sequence data with the aim of inferring, what is actionable to public health. His program, his open source software NextStrain, which I'm sure many of you know about. This has been really helped to popularize and refine genomic epidemiology, particularly now during this COVID-19 pandemic. And with the Seattle flu study, he led the design and implementation of a next generation infectious diseases surveillance system. And this has impacted both local and global response to the pandemic. So two very esteemed speakers on this topic, and we look forward to hearing from them. So we'll hear first from Christian, and then he'll hand over to Trevor, and then we'll leave about 10 minutes at the end for Q&A for both of those talks. So welcome, and thanks again for agreeing to speak.
Thank you, Nikki. Thank you, the Africa CDC PGI for this invitation. And again, glad to see my friend and brother Trevor, after such a long time, because pandemic has set us apart. I go straight away into the presentation and then share my screen so that we can all move on with the presentation. So to get started with, sorry, I think I should be out of here for now. I don't know. This is not the slide I'm supposed to show. I think it's somewhere. Okay, sorry. All right, so I think Nikki, the PGI said we should talk about real-time genomic surveillance for public health response in Africa. So, and Nikki has done the introduction. So the Africa Center of Excellence is the WHO, Africa CDC, World Bank Reference Center for Genomic Epidemiology, Surveillance, and Research Innovation, Infectious Disease Research Innovation in Africa. We are at Redeemers University in Edinburgh. And we basically just use genomic as a way to address one of the major healthcare challenges in Africa. So, and then that definitely it is infectious disease. And the reason why we use genomic is simply because, with the advance of genomic sequences and then the fact that the human genome and then the genome of numerous organisms have been sequenced, that has really revolutionized the way we approach healthcare and research. But a few years back, we realized that many of the technological and economic innovations and an economic benefit, accruing from the genomic revolution really have not been benefiting Africa simply because there was no know-how on the ground and then there was also no infrastructure. So in order to address this gap between Africa and the rest of the world, because we observed that created a huge gap, so we definitely decided to set up a platform, and then that platform was definitely the Africa Center for Center of Excellence for the Genomic of Infectious Disease. And the reason why we actually focus on genomic of infectious disease is because of this map that you see here. If you look at this map here and then add in COVID probably that came from China, then you realize that the majority of of pathogen that do have pandemic potential, emerge from Africa. And then as such, Africa should be the leader or global leader when it comes to infectious disease genomics and then research and developing countermeasure for infectious disease for the rest of the world. And and then we set up this platform that is built around, academic and the clinical testing centers in Africa to address this problem in collaboration with international partners, Harvard Naturally, the Broad Institute, and others, and then the private sector partners like Illumina and then Dimagi and then Forgenix, which were people that we started with. But then this partnership has become so broad and then includes so many other partners that really we're working with to make a difference. So our missions definitely are twofold. One is education, and then the second one is research. So in our education, we really think that we can use the AG platform as a way to create a vibrant and academic environment, a research environment that transcends national boundaries, where Africans and then collaborators and partners will come and conduct relevant, responsive, highly ethical, and then translational genomic research in Africa. And specifically, we think that we can definitely we've been able to demonstrate that we can actually build a critical mass of well-trained African scientists that can harness, knowledge of genomics and develop tools, toward prevention, control, and elimination of infectious disease. But in order to do that, we also thought about it was important to, in order to provide knowledge to create genomic curricula, and then in order to provide or promote cutting-edge genomic-based research, and finally also engaging communities in prevention and then public health, education. Then this education goal is highly supported by research, and then the research program is actually driven by understanding, the drivers of febrile illness on the continent, because we know that generally most febrile illnesses are characterized by fever. So we basically use fever as a way to understand the drivers of infectious disease or febrile illness on the continent. So one of the first demonstration of how we could use genomics as a way to respond to public health in real time really happened during the 2014-2016 outbreak in West Africa. And then for the first time during an outbreak, we were able to use genomics as a way to not only gather information, but also use such information to guide public health response. And this was quite revolutionary at the time, even though at the time it was very difficult. The first thing we did at the time was really in the first 3 weeks of the outbreak in the country, in Sierra Leone, for instance, we were able to sequence the first 99 genome of Ebola virus and made these genomes fully and openly available to the international community. So in reality, we actually pioneered open data sharing and open data access, at that time, for infectious disease or for epidemic response in Africa. And we're very glad that what we pioneered at the time in 2014 has become where the scientists are depositing all the data in this set and then shared with the international global community, and that really is a model that we created and we pioneered in 2014. And that really was very helpful, to developing rapid development of vaccine against Ebola, rapid development of drugs against Ebola, and then development of novel diagnostics and then creating rapid diagnostics. So what we did at the time was unprecedented. From sample collection to depositing the data, in GenBank, we actually revolutionized the process and did this in 10 days. And we were not doing it for fame, because our paper, for instance, having made the data openly accessible and available, could come out only about 8 months after we deposited the data in GenBank. So, and we were able to use, Ebola, first of all, the use case of Ebola to demonstrate, for instance, the case of Sierra Leone, where you will see here that we had 4 different lineages of variant between April and July 2020 and 2015 in Sierra Leone, 4 different lineages that entered the country. And that really was the first time where you could use genomics to show all these lineages coming in. And then if you look at this diagram over here that I'm using, this laser pointer to see, between May and June, you will see the different variant coming into Sierra Leone, SL1, 2, and 3. But what is interesting about this diagram is the fact that by June 16, SL3 has taken over. And this was the very first time where you could demonstrate, that variant with mutation actually could, some variant with additional mutation or with submutation became more transmissible than others. So, and then we were able to show that, the increase or what was quelling transmission in Sierra Leone at the time was actually due to sustained human-to-human transmission. There was no no additional introduction from zoonotic reservoirs, and then there was no imported, viral diversity from other countries. So, and that really was a very first use case. Then over time, we observe accumulation of mutation across the genome. One of those mutations became fixated, and then we demonstrate increased transmissibility and actually propagating transmission of the virus in the region. But interestingly, we also, for the first time, use, genomic, and then time in order to show, within the country. So we were using it to point transmission from county to county, from country for district to district, from country within the country, and then from countries, and then between countries across West Africa. So that's what you usually just see here in real time, and space to see how this actually happened. And this really enabled us to identify those viral genome, how genomic will reveal those factors that were involved, for instance, in the spread and the sustainability or in the spread and sustain of the Ebola virus in West Africa. But apart from just doing the real-time diagnostic, real-time genomics, we also realized that it was important to translate the genomic data into point of care or point of need diagnostics, because we saw during an outbreak that many people that had malaria fever, for instance, going to the Ebola triage center because they had fever, got infected there, and then came back and infected more people. So there was a need to develop real-time diagnostics, and we were able to translate that, and then the genomic data, and then with partners, and then develop the first rapid diagnostic test, for Ebola virus disease in 2015, and that was the very first generation test that was approved under emergency use authorization by the WHO and the US FDA. And the introduction of this test, in the region was a major turning point in order to bend the curve or to flatten the curve, as people would say. And that really actually showed the power of genomics when it comes to epidemic control. Now, the second use case I will talk about is actually a disease called Lassa fever. Lassa fever is a disease that is located in West Africa that killed thousands of people in the region, and a disease that was reported for the first time in Nigeria in 1969. So as far back as 1987 or 88, 2007 or 2008, sample from patients with this disease in Germany, and then for analysis. And often when the diagnosis were confirmed, 90% of patients with this disease were dead, because there was no way to actually determine early enough that they had Lassa and eventually treat them accordingly, even though there is the drug called ribavirin, to treat this disease. Of Lassa fever in Nigeria, confirmed the first cases, but in 2013 we've actually set up the first NGS on the continent, within the region, and then did the very first next generation sequencing of this virus. We're able to actually just sequence, virus from 400 patients, and then also on rodent, but then through that, establishing the largest catalog of this virus. But then this catalog actually taught us a whole lot, in the sense that it helped us not only to identify the real age of this virus, we eventually found that the virus was about 1,060-year-old, was circulating within Nigeria for 600 years, moved out of Nigeria 400 years ago toward the West, and then that really helped in understanding, this virus, and then helped to develop countermeasures. So this work was done in collaboration between Christian Anderson, participating, and myself. We not only just understood the virus, but we also used the origins of the virus, but we also used that to develop rapid diagnostic tests, and then we're able to establish the first pan-Lassa rapid diagnostic.
This is a screen showing the ancient origins of the Lassa virus.
But in
Specifically,
addition to that,
we are talking about the
really
Ebola here.
to be very helpful.
And there are a lot of information that is being shared by Professor Christian Happy. Kindly keep in touch.
Published. And 2020, there were 3 different vaccine candidates that have been developed, and then 3 of them are undergoing. Information become very important. And then also Genomic actually demonstrated its utility one more time in 2018, when Nigeria was facing an unusual surge of the number of Lassa fever cases, early in the year. In the first 8 weeks of 2018, in Nigeria observed a 200-fold increase, in the number of Lassa fever cases. That is combining, having more cases in 8 weeks than in the past 2 weeks. In the past 2 years combined. There were many unanswered questions, and then those questions were we dealing with new variant, were we dealing with a more variant strain? Was this surge due to human-to-human transmission or increased transmission? Or is it that the fact that our diagnosis were not effective? We went in and quickly sequenced over
Of course, there was a Lassa fever surge in 2018, and this is one of the public health problem and challenge.
Across Nigeria. Working in collaboration with the with the Nigeria Center for
That
Disease
is the
Control,
local real-time genomic response.
very quickly with answers. We were able to sequence the genomes and ensure exactly what was going on in country. The data were being shared in real time.
Then there is what is called the sequencing of the genomes at a real time. And that genomic data addresses the key public health questions, and it helps us to understand of the Lassa virus population, which is across Nigeria.
Similar for the world, the known lineages, that is lineage 1, 2, and 3. But what was interesting about this is that we found that, lineage 3 was clustered in the northern part of Nigeria. Lineage 2 that we knew before has split into two. 2A, lineage 2A in the southwestern part of Nigeria, and then lineage 2B in the eastern part of Nigeria. But more interesting was the fact that these three variants or lineages were actually just clustered geographically and were basically separated by major natural, what we call geographical barrier. So for those that know Nigeria, you can see here, this is a Niger river, and then this is a Benue river, and then you got a Niger river. So, and this was very clear that the mastomas or the reservoir were driving this because, those mice cannot swim and cross all these large rivers. So it was very clustered, very clustered. This information was shared directly with the Nigeria Center for Disease Control. In addition to that, we identified some clusters of transmission, or through nosocomial transmission in hospital. These clusters were between 2 and 8 different patients. We had this published in the New England Medicine, but what was important was the fact that they shared with the WHO and the Nigeria Center for Disease Control, and that really helped to stop this introduction. And here you can see here, this was a WHO.
That is the genomic data informing the outbreak and the response. Of course, you're finding the shared with the NCDC, genomic data received, and the Lassa virus genetic diversity, especially in the rodents in Nigeria. And this was one of the cases that was rampant in Nigeria in 2018, where there was an increase in it, where there was a largest Lassa fever outbreak, and of course that was sparked by the rats in Nigeria.
So, and that really also helped in terms of, again, translating once more time, these findings into developing point-of-care diagnostics that are cheaper and better, probably than PCR. So, and then Amy Matson from Nature embedded in our lab for 1 week, and then it was able to actually show, how we were able to develop the first CRISPR-based diagnostic for detection of infectious disease that was faster, better, and cheaper. And then you can see here people in my lab working and then using this facility. Now, the next thing I will talk about is how we're able to use metagenomic, and then perform the largest.
Of course, like the metagenomics of the clinical samples and how the identification of the part was based on this sequence and discovery of the novel, and that is rhabdoviruses. That occurred in the rats, and most of them are maybe the snakes and the rodents.
With symptoms that are very weird, and then diagnoses are negative. And yet, they have febrile illnesses, and then eventually, we found that, using metagenomics, we discovered 2 new viruses. And these viruses were called the Ecomavirus 1 and Ecomavirus 2. These are rhabdoviruses that were very much associated or have a high similarity with another rhabdovirus called the Bakongo virus that was discovered in the DRC in 2012, and that was responsible for a viral hemorrhagic fever out there. So this information, again, shared with public health authorities in Nigeria was very helpful in order to understand the origin of the new viruses and then how that could be associated with viral hemorrhagic fevers. So this is another use case, for instance, that was driven by one of my graduate students, now a doctor called Victoria. And this was a case whereby in 2018, toward the end of 2018, November to be specific, within a week, Nigeria lost 179 school children. The source of death, or the pathogen, responsible for the death of the children, actually remain unknown because all tests for Lassa, for Ebola, for yellow fever, everything, proved to be negative. So 22 samples were sent to a lab, and then we were able to use metagenomics to sequence. And within 48 hours, we established that we were dealing with a new, the yellow fever variant that was very distinct from the ones that have been circulating in Nigeria in the past 94 years. This information was shared immediately with the Nigeria Center for Disease Control. They declared an outbreak, and within 2 weeks, they were able to successfully contain that. So again, the third use case, again, another use case here is a situation whereby obtaining sample from patients with tuberculosis in Western Nigeria or in Nigeria, we identified the very first more extensively drug-resistant tuberculosis in Nigeria and then West Africa. And that information shared again with public health authorities made us understand that we're dealing with, a bacteria that actually was uncommon and that has come into Nigeria, and then really was very important to start actually monitoring the extremity of resistant TB. So, but apart from just doing the sequences, we're also working, in developing the pipeline. Here, these are two different pipelines, one for Genomic and then one for Genomic, developing my team. And you can see here, Paul and they will develop in this for analysis, and then really helping those in the developing world to actually assess the information. And then with this pipeline, you could do either Genomic assembly or Genomic assembly on your laptop without needing to go and then use multiple, source for multiple platforms or software in the world for perform analysis. And we don't just focusing on, we're not just focusing on human diseases. So this is a case of a case of Dr. Happy in my lab that actually characterized the very first rabbit hemorrhagic disease in sub-Saharan Africa through microbial metagenomics. So this is a situation where rabbits were dying, and then this has potential to become zoonotic. So, and then we were able to collect sample, went on to sequence and discovered that we're dealing with the rabbit hemorrhagic disease, rabbit hemorrhagic virus. And this again was shared with RE, and then this again also helped a lot in terms of containing this out. So this basically just showing pictures of this. Now, when it comes to COVID, and Nikki mentioned COVID. So when we had when COVID started in Africa early in 2020, so we were pretty much prepared with all the battery of technologies and the sequencing platforms available in my lab. So in Nigeria, for instance, we received a sample from the Nigeria Center for Disease Control in a very powerful collaboration with the Lagos State Ministry of Health, the Nigeria Institute of Medical Research, and the Nigeria Center for Disease Control. We went on to perform the sequencing in an unprecedented time, 48 hours. This really, is a record time that is remain unmatched. We shared this information immediately with the global health community. And this really paved the way for Africa to actually understand that they can rise to the occasion. And this really helped Africa to understand that they could do it, and they could also contribute by providing information and sharing, also sharing with the global database. We performed the first SARS-CoV-2 genome sequence in Africa, and we were able to establish the source and the origin of this virus from the Nigeria index patients. We, over time, continue to work in very close collaboration with the Nigeria Center for Disease Control, sharing information in real time, making information all available every week so that the Presidential Steering Committee or the Presidential Task Force will actually use information in order to make decisions for the country. So over time, and then learning from Trevor and everything, you can see here the next train.
So we have now genomic epidemiology of the novel coronavirus, that is SARS-CoV-2 in Nigeria. So you can be able to find the information as we shared in our screen here. That is the genomic epidemiology of that novel COVID-19 virus.
From about over 32 of the 37 states in Nigeria, and these informations are available for public health authority. With tracking the virus and spread over time, you can see here over time. So you can see here over time how these variants are actually spreading. Here this is a bump with Delta. You can see the bump with Omicron, and then that has taken over. So these informations are very helpful. So we've also used this as a way to translate this information, the genomic sequence data, into developing a point-of-care diagnostic that can detect, the virus in 5 minutes, and then also help to actually, that is cheaper, and also help to navigate the outbreak response. But more importantly is that with all of the ability that we have, we've been able to capture and then multiplex all of these tests, for instance, that is bringing together all of these diagnostics in one single platform, in one single chip. And now we have the ability to actually test over 169 different viruses in one, or pathogens in one single test. And that really is very important for real-time diagnostics, detection, and then informing public health authority. But we've not only done the research, we also train and build the capacity across the continent over over the past few years. Training over 1,000 participants in different courses. Here you can see the map here. So over the past few months, past 2 years, we've been able to train over 32 different people from 32 different African countries, and now also supporting sample sequencing in about 30 different African countries. And that really has been responsible for the major surge that you saw in Africa, because leveraging all of the testing center or the sequencing platform available on the continent with other partners.
This is a major milestone, especially leveraging the available continental genomic platforms for SARS-CoV, and we can be able to look into that, the phylogenetic reconstruction across the continent, and this has been one of the greatest success as per Africa CDC.
Making significant contribution not only in countries and helping African countries to respond to the epidemic, but also helping the global community to understand disease transmission in real time. And all of these efforts in terms of capacity building and leveraging the resources in Africa has really helped the continent in order to respond, and then also to generate an incredible amount of data. If you could see here in 2020, in December 2020, Africa has just done only 5,200 sequences. But with the capacity building and the training and the technical assistance that we provided, along with the PGI and then many other partners, the Rockefeller Foundation and many other partners, Africa by September has produced 60,000 sequences. 60,000 sequences in a year. As I'm speaking to you, we're over 100,000 sequences. Again, it is due to the ability to leverage, to help one another, and also to provide information. So, and this information, all of this information are often given in real time to governments, and then they use this information in order to respond to local epidemic and outbreak. So I'll be ending this by actually just presenting this new initiative that I'm leading with participating. And this initiative actually came before this pandemic. We were really thinking about pandemic preemption and response system that were based on 3 major pillars, right? And this initiative actually proved to be very helpful, because we did this before the COVID-19 pandemic, but actually demonstrated to be very helpful. So this initiative that I will call all of you to key in is actually, I believe is revolutionary. Revolutionary in the sense that it is built on 3 major pillars. The first one is detect, that is using genomic technologies to create, to detect early enough known and unknown pathogens before they get to us. The second pillar is connect, that is connecting the information, that is the diagnostic data and information in real time to public health authorities and in public health networks. And then the third one is empower, that is basically empowering front healthcare workers that are already in the field in order to use the genomic technology, and then connecting this information in real time to public health authorities in order to not only respond to pandemic, but also to prepare pandemic and respond to pandemic. So you can see here where we have a battery of different ways of detecting pathogens. Generating point of need diagnostics, the way I explained to you, in the peripheral healthcare center, that is on multiple places. This is within hours. If they are negative, then the samples are sent to the next hospital where we could multiplex the way I explained to you, looking at 196 different pathogens in one single test. If they false negative here, again, the samples are sent to the genome centers, and then the genome centers will use next generation sequencing and metagenomics to identify what could be responsible. As I showed to you, we can use then those sequence data to create new diagnostics, and those diagnostics will be sent back to the front line. But while these genome sequences or the diagnostic data are generated, they are captured immediately and sent back to public health authorities to the Connect platform that is using data science and information technology. And then thirdly, it is empower, that is empowering public health community, and then strengthening the health system for pandemic preemption, not only in Africa, but elsewhere in the world. So we started piloting this in Nigeria, and then that has been going successfully. But then we really extending this platform to Senegal, Sierra Leone, Liberia, and other West African countries in the DRC. And then we're working in collaboration with the Africa CDC, hoping that we could actually make this a very good continental platform. All of the platforms that we are developing are not working in isolation. They are interoperable, which means that they can be integrated in the existing platforms all over on the continent, so that we don't disrupt, what is already established, but actually enhance and add value to what is existing already in the platform. And this is the kind of stuff that we want to end up with, like dashboard. This is a case, of Nigeria, where you could see a single dashboard where you can have information on the different variants, where you can have information on, different states. And this is in real time, whereby you could show this data and then compare a trend over time and within days, and then have a map of the country with the heat map. You can see here where the different demonstrated this by showing this to the governor of Lagos State in Nigeria. And then this really was fascinating because he could see that on his dashboard. He doesn't have to wait for a meeting, but at least on his cell phone, he can actually see the situation, in his own state or having the situation in his own country. Can compare what is happening within his state and then what is happening in other part of the country, or can compare what is happening in his own state and then the rest of the world. Providing all of this information, clinical data, transmission data, mutation, and relating this not only to one disease, but also doing this to multiple diseases will actually be very helpful. And we believe that through this kind of application and then through this kind of approach, we believe that we can actually expand the scientific capability of Africans to enable sustainable independence, surveillance, outbreak, and pandemic response in the country. So I really want to end this by thanking my team and then for working extremely hard over time and then to make this happen. This is just a few of them, very large team. But I also want to acknowledge, our outstanding, partners and our outstanding and then our funders who have really supported all of this initiative over the years. I really thank again, the PGI and then Nikki and then everybody for the opportunity to present here. Thank you.
Thank you, Christian, for that brilliant presentation and for the phenomenal work that you're doing across Africa, not just for your own institution, but really helping everybody across the